All right, good morning. This is on page 23 of your Unit 2 packet. We're going to be using what's called the remainder theorem today. A remainder theorem is just exactly like it sounds. You are looking for the remainder at the end of doing synthetic division. So we're going to be practicing that a little bit more. The theorem states on page 23 that if a polynomial function is divided by a, so this is the factor, the remainder is going to be kind of like an ordered pair. Whatever number you plug in, the remainder will be what comes out at the end. So it's really no different than what we've been talking about when we're doing long division or synthetic division. Sometimes you will end up with a remainder at the end and sometimes you won't. So there's actually several different ways you can do this. So use the remainder theorem to evaluate. Okay, so we can do synthetic division one way. So the number we're dividing by outside, so -3. And I put the coefficients in order, so I have a 2, a -4, a 0 because there's no x, and a 1. Pull it down, 2, multiply, -6, add them up, -10, multiply, I get 30, add them up, I get 30, multiply is -90, add them up is -89. The remainder is exactly what you think. It's at the end. So this is your remainder. Now, there are a couple other ways you can do this. So, sorry, let me finish. So when I plug in -3 for my x, I get the remainder of -89. So, a couple other things you can do. So this is one option. If it asks you to get the remainder, figure out the synthetic division. A second option, you can also go to the function, so 2x cubed minus 4x squared plus 1. And you plug in -3. So f of -3 is 2 times -3 cubed minus 4 times -3 squared plus 1. So plug it in just like you would any other one. So let's see, so this is 2 times -27 minus 4 times 9 plus 1. 2 times -27 is -54 minus 36 plus 1. So -54 minus 36 plus 1 is the magical number of -89. So you can plug it in also. Or the third way, you can go and do it and say, go to your calculator, push y equals, clear off what's ever in there. So 2x raised to the third minus 4x third over minus 4x squared plus 1. And this time, instead of going to the graph, because we're not looking for the graph, we're actually looking for a value. I want to go to the table, so I'm going to press second and then graph to go to my table values. And I want the x value to be -3, so I'm going to go to -3, and what do you know? I get -89. So feel free to use the graphing calculator also to do that. So any of these, when it says use the remainder theorem, see if there's what the remainder is. The last number in synthetic division is your remainder, or plug it into the function itself, or go to the graphing calculator and get the value from the table. So whatever you're comfortable with, it's not challenging, but it's just something different. We call it the remainder theorem. So this would be a good time to pause. Try example number 2. Put 2 into that function and see what you get for the remainder. 2 outside, I got 6, -19, 16, -4, 6, 12, -7, -14, 2, 4, and 0. All right, so for me on this one, the remainder is 0. So my order pair would be 2, 0, or I would say remainder equals to 0. So either one of these answers, when I ask you about what the remainder is, either one of these would be fine. If you want to write out a sentence into it, that's fine. I'm just going to double check and show you again. Raised to the third minus 19x squared plus 16x minus 4. Go to my table, so second table, and I want positive 2, and therefore you have a 0, which means, so you don't need to write this on stuff, but technically you need to know that as going forward that this is going to be an x-intercept. Or also we call it 0. All right, so going forward, the factor theorem now, it incorporates the remainder into it. So the factor theorem says a polynomial function has a factor of this when the function itself has 0 for the remainder. So that's when you see when I finish with the 0 and I check it, that for me indicates that I have a 0 and that's where I'm ending up at. So when you are asked to show, like on this problem, show these factors are functions of this and then find it, they're saying these are supposed to end in 0. So if they don't end in 0, there's a problem. So start with either one of these. Now remember, my factors are x minus 2, which means my 0 I set equal to 0, and this is the number I plug into my synthetic division. So when I'm doing synthetic division, so I'm showing it works, I'm doing synthetic division. 15, positive 36 minus 9 plus 9. This would multiply and get 18 and end up with a 0. So I am showing that because I have no remainder, I know for sure this is a factor, so this one checks out. Now, here's the thing. If you're asked to do multiple factors in a row, don't start over again. So I worked with 2, and it works, and I have that. Work with these numbers now. So keep going down. Don't rewrite the whole problem or scratch these out. So keep working with this. So I want to show my next one is x plus 3. So I want to show that negative 3 is also a factor. So I'm going to do my second synthetic division in a row. This is an 18 here. Okay, so I did it first with this one, it's fine. And now I'm going to plug the negative 3 in here and keep going with it. So 2 falls down here, I have negative 6, I have 5, I have negative 15, I have 3, I have negative 9, I end up with another 0, which shouldn't be a surprise because I want to show that's a factor, so that one works. Now, the rest of the problem says find the remaining factors, which means I want to take what's at the end here, plug the x's back in, and then continue my factoring process. So not find more zeros, but find the other factors. So we talked about initially when we started doing synthetic, this starts up as 2x to the 4th. One level down, it goes down by 1 exponent. So now this, when I started the negative 3, is x cubed. So going down here, so now this is another level down, so this is x squared. So I have 2x squared plus 5x plus 3 to factor. Okay, so good time, stop, practice your factoring, pause it. So here are the other factors. Okay, it doesn't say find all of the zeros, it says find the factors. So I have x minus 2, x plus 3, 2x plus 3, x plus 1. It's a degree 4 because it's the biggest exponent, so it should have 4, 2, 3, 4 factors, and that would also lead me to be 4 zeros. Okay, so this would be a good time to pause it and try example 4. show it's a factor, so I'm going to use x equals -1. Okay, so welcome back. If you paused it, I showed that x plus 1, so the number -1 is a 0. I have the 0 remainder. My other factors, I had to do this synthetic division until I got x squared minus 3x minus 18. Now I have x minus 6 for my other factors and x plus 3. Alright, so the summary. The remainder r obtained by dividing f of x by x minus k tells us when r is equal to 0, then the factor x minus k when r, and the factor x minus k is a solution or 0. When r does not equal 0, oops, get rid of that. When r does not equal 0, then the factor x minus k does not factor into the function. Okay, so that's it for today. Thank you, and your homework is going to be to evaluate the function using remainder theorem, so use any of the ways on page 25. Use the remainder theorem to divide out the to decide if this is a factor or not. Explain your reason why. More remainder theorem. More remainder, and so on page 25 and 26 is going to be your homework. Thank you.